Open your packet to page 17 and 18 for the graphing form of a quadratic equation for a parabola. This is going to be the rules that we're going to use that are going to govern the movement of a vertex of a parabola, and are going to be the rules for A, which is going to be how wide or skinny the parabola is going to be. So the general form of a quadratic is y equals a times the quantity x minus h squared plus k, where x and y are the variables. The parameters are a, h, and k. Notice they come in alphabetical order in the equation, a, h, and k. And the vertex of the parabola is h comma k. Those letters, H and K, are always going to be the vertex of any of the shapes that we are going to talk about for the remainder of the chapter. It is always going to be HK used for the vertex. Okay. All right. How do we make the graph of y equals x squared, their parent graph, move? So if I want the graph to move up, I'm going to make my last term K to be positive. So my equation is going to look like something y equals x squared plus some number. Maybe it is 3. So y equals x squared plus 3. So that is going to take my parabola, general form y equals x squared, and is going to take that vertex 3, and it is going to move that vertex of my parabola up to 3. Notice the shape of the parabola is not going to change. It is only going to move the vertex up 3. If I want to take the graph of y equals x squared and I want to move the vertex down, then I'm going to make the k term negative. So in my equation, I'm going to make k negative. So I'm going to have y equals x squared, and now k is going to be negative, so maybe negative 2. So on my y-axis, negative 2. So that is going to take the vertex and move it, shift it down 2. Again, notice the parabola itself did not change. I'm only shifting the parabola down 2 units. So to move my parabola up or down, I'm changing the last term, the k. Much like slope-intercept form, the y-intercept, the b, either positive or negative, whether I'm shifting it up or down. How do I get my vertex to move left or right? Well, if I want my vertex to move right, I'm going to make the h term in my equation to be positive. It's going to look negative in the equation. So for example, my equation might be something like y equals the quantity x minus 2 squared. That means h equals 2 in this case. So here, that means h is 2. So the vertex h is going to shift my parabola 2 units to the right. Again, the parabola size and shape does not change. I'm just shifting the vertex 2 units to the right. To move my parabola to the left, we'll move over to the next page. Copy the general form of your equation here at the top. To move your graph to the left, you're going to make h negative. So your equation is going to look like y equals x quantity x plus 3 squared. That is going to move your vertex over here to negative 3. So it's going to shift the vertex of that parabola to negative 3. Notice how it looks like it's positive in that equation. The reason for that is when I break this apart, if I think back to our algebra 1, I really have x minus negative 3 quantity squared, because x minus a negative, that's really x plus 3 quantity squared. So here h is really a value of negative 3. So I'm moving my vertex to the left 3 units. So now we know how to move our vertex left, right, up, and down. What about A? Well, A tells me what happens with my graph, okay, to move the shape of my graph. Okay. So it's not moving the vertex, but it's telling me what happens with the shape. So if I want my graph to be flipped upside down, we make A negative. So my equation would be y equals the opposite of x squared. This means A would be negative 1. So my graph would take this, it would be flipped upside down about the vertex 0, 0. It just completely flips this graph upside down. The vertex does not change. So if A is a negative 1, it flips the graph upside down. What else can A do? Well, A has the ability to take this graph and change the size. Because so far we've just taken the same parabola and just moved it, shifted it around the graph. I moved it left, right, up, and down, and flipped it upside down. Okay. But the parabola itself does not have to stay the same size. Okay. I can take my parabola and make it vertically stretched, meaning I can make it skinnier. That happens when my absolute value of A is larger than 1. For example, if A were 2, then my equation would say y equals 2x squared. And my original equation would show my parabola being skinnier than the original. We call that vertically stretched. It could be a combination of things. I might have A equals negative 5. So my equation would be y equals negative 5x squared. So the negative is going to flip it, and the 5 is going to make it skinnier. So it's even going to be skinnier than x squared. So it's going to be yet skinnier. We saw this when we graphed yesterday on Desmos. So it flips it upside down and becomes skinnier. A can also make it vertically compressed. So think about compressing, like I step on a grape. What happens? It becomes smushed. It becomes wider. It presses it out. That happens when A, the absolute value of A is between 0 and 1. It becomes a fraction. Okay? So for example, if A is 0.5, okay, or we know as a fraction that would be 1/2. My equation would be y is 0.5 x squared. That means it's going to be vertically compressed. It's going to be a graph that is wider than my typical parabola. If it also has a negative sign, maybe A is negative 1/10, then my equation would be y is negative 1/10 x squared. Then the negative would flip it upside down. The 1/10 would make it even wider. So y is negative 1/10 x squared. So A has the ability to flip my graph, make it vertically stretched or vertically compressed. To practice these skills, go back to page 16. Okay. Copy the equation at the top, and let's take a look and see if we can identify my components. Okay. So for number 1, identify the transformations. The first thing we should do is look at my graph and find the vertex. Okay. So my vertex is at -2, -1. That tells me my H and my K. Identify my graph. Is it a normal looking parabola? So here's my vertex. I go left 1, up 1, right 1, up 1. So left 2, up 4, right 2, up 4. So yep, that looks normal. So I know A is 1. So it is a normal looking parabola. It is not vertically stretched or vertically compressed. So when I identify my transformations, I just identify the location of the vertex and its movement. So the vertex went left 2 and down 1. When I write my equation, I just now substitute in H is -2, K is 1 into my equation. A is 1 because it's the regular looking parabola shape. So when I substitute in, Y is X minus my H value of -2, so minus negative is plus. So X plus 2 quantity squared minus 1. For the second one, identify my vertex. So my vertex here is at 0, 2. So there's my HK. I can see here that it is flipped upside down. So my first value that I'm going to write for my transformation, it is flipped. I know A is negative. So let's check my values. Left 1, down 1, right 1, down 1, left 2, down 4, right 2, down 4. So A is -1. My vertex just moves up 2. It does not move left or right, just up 2. Now to write my equation, Y equals A is -1, X minus H of 0. So X minus 0 is just X squared, and K is up 2, so plus 2. So -X squared plus 2. And now at the bottom, we need to graph. So sketch it. So X minus 3. So this means we went right 3. And here we go up 1. So right 3, up 1 gives me my vertex. This says A is 1, so it is a normal parabola. So right 1, up 1, left 1, up 1, right 2, up 4, left 2, up 4. Sketch your parabola. Here, A is 1. H, I'm moving, in this case, left 1. And here, down 2. So left 1, down 2. A is 1, it is normal. So right 1, up 1, left 1, up 1, right 2, up 4, left 2, up 4. Sketch your parabola. All right, good luck.